George Matsumoto received a degree in marine botany at UC Berkeley and a PhD in biological oceanography with a focus on jellies at UCLA. He has taught at Catalina Island Marine Institute and also worked as a lecturer in marine biology at Flinders University in South Australia. Currently, he is the Senior Education and Research Specialist at the Monterey Bay Aquarium Research Institute, and he's also very committed towards education at the undergraduate and graduate levels. So welcome, George.
Thank you very much, Jason, and thank you to everybody for attending this morning. I'm going to jump right into it because I know we're running a little bit behind today. First, I'll acknowledge our land use at the Monterey Bay Aquarium Research Institute. MBARI is located on the unceded land of the Hueneren and Guacharon peoples. This area was home to a settlement called La Cuesta in the region of Calandaruk, which means ocean home place. The native peoples of this area were taken to Mission San Juan Bautista and Mission San Carlos Borromeo de Carmelo. The native people taken to Mission San Juan Bautista are represented today by the Ama Mutsun tribal band, and we are fortunate to be able to work on this land acknowledgement statement in partnership with the Ama Mutsun Land Trust. And I just want to talk a little bit about accessing the ocean and deep sea and open ocean exploration. And accessing the deep sea has been a challenge ever since people have started looking into the ocean and trying to figure out what's going on in there. Early days, the Challenger expedition in the 1800s was a 5-year voyage going all around the world, trying to dip nets and take soundings to try to figure out what lived in the ocean. Many of the things that they found are recognizable today, mostly because we've been able to go back in with better technology. In the early days, they used nets and tows and dredges, and most everything that came up was kind of mush, except for fish and crustaceans, which survived the rough collection process fairly well. Our founder and mentor, David Packard, in 1987, had a clear vision for how this brand new research institute would tackle the challenge of trying to explore the ocean using technology. And this vision was different from most other oceanographic institutions. Most people at that time were using human-occupied vehicles, like the Alvin that you could see in the left-hand picture. The Alvin is currently the United States' only human-occupied research vessel, and it's capable of going down to 6,500 meters now. David Packard thought we should use technology and use a remotely operated vehicle. And so in 1989, we launched our first remotely operated vehicle, Ventana, and that's what you could see in the right-hand picture. And I'll talk a little bit more about our remotely operated vehicles in a minute. His vision focused on creating partnerships between scientists and engineers. This again was fairly unique amongst oceanographic institutions because here we have scientists and engineers working side by side on an equal basis, where the scientists could come up with projects and the engineers come up with projects. And every project at MBARI has a scientist and an engineer working together as co-investigators. He also insisted on data management. And in the 1980s, this was fairly unique because nobody thought we'd be able to collect that much data. And today, we know that we could collect more data than we could possibly process. And in fact, that's one of the big challenges right now. And one of the things MBARI is working on is machine learning to try to get computers to help us deal with the vast amounts of data coming in a never-ending stream, because we're collecting data now 24 hours a day, 365 days a year. We're located in Moss Landing, which is on the California coast, halfway between Santa Cruz and Monterey, about 2 hours south of San Francisco. And the neat thing about this particular location is the Monterey Submarine Canyon, which stretches down to a depth of 4,000 meters and cuts Monterey Bay almost in half. And what it does is it gives us easy access to the deep sea, because within an hour, hour and a half of leaving the dock in Moss Landing, we could be working in 2,000 meters of water. And that's really nice. Just to give you an idea of the relative depth, Monterey Canyon stretches down to 4,000 meters, as I said before, roughly equivalent to the Grand Canyon in size and scope. And so what MBARI does is try to take a systems engineering approach to solving problems, with the idea that if you have good systems engineering, you're going to find out not only the things that you hope to find out because you've designed your experiment and your project in a good fashion, but you'll likely also find unanticipated discoveries and new opportunities. And the unique thing about MBARI is that we have the opportunity to go long and take risks. Because we're a private nonprofit research organization, we're funded primarily by the David and Lucille Packard Foundation. And so we consider that hard money. In other words, we go to the Packard Foundation every year. We ask them for an annual budget, and every year for 30 years, 30 plus years now, they've given us our annual budget that we've asked for. Last year, we surpassed the $1 billion mark in funding from the David and Lucille Packard Foundation. And so because of that, we could do projects that other people can't do, because when you're relying on external funding like federal funding, they're not going to wait 20 years for results. They want to have results in a couple of years. And we know that the ocean is undergoing very rapid change, both in its chemistry and biology. We have ocean warming, oxygen depletion in the ocean acidification, as well as coral bleaching that have all hit the news. And so what we're trying to do is develop or adapt technology to advance our understanding of the ocean, not only explore how the ocean operates naturally, but also learn how it responds to human activities, and then share that information that we learn with everybody that we can. Our blueprints for achieving that goals are to try to pick problems that are global in scale, but are also apparent locally, so we could work on them in Monterey Bay. Measuring ocean change is the unifying theme. Turns out there's lots of things that humans are doing to the ocean. And the major priorities really push our engineering investments. We want to spend more time in the field, not in the laboratory. We want to be careful about our sampling process, because we don't want to just go out and harvest the ocean. And we want to try to spend as much time in the ocean as possible, really develop a persistent presence, which, like I said, means 24 hours a day, 365 days a year. And then whatever we develop locally, we want to share globally. So MBARI does all kinds of amazing things, and you can look on our website to learn more about it. I also want to talk about two other programs that MBARI is running. Not necessarily polar programs, although it's kind of cool to go out into the Arctic or the Antarctic regions, but it's really expensive. Research vessels are expensive. And with Ventana, our remotely operated vehicle that goes down to 1,800 meters, we use a day ship that goes out about 160 days a year, leaves the dock at 7 in the morning, comes back at 4:30. We get a 6-hour dive in with the remotely operated vehicle. That runs about $25,000 a day. With our larger research vessel, the Western Flyer, that uses this remotely operated vehicle, you could see behind me the Dock Ricketts. The Dock Ricketts is a 4,000-meter remotely operated vehicle. It goes out on longer expeditions on our research vessel, the Western Flyer, and they'll go out to sea for up to 2 weeks at a time, and they'll do 12-hour dives with that remotely operated vehicle. Those days cost around $36,000 a day. And we also operate the Western Flyer 150 days a year. Going down to places like the Arctic or the Antarctic are going to be just as expensive. And so what MBARI has been working on are ways to collect data and do research without actually having to pay for ship time. And one of the things we've been doing is this program where we are putting biogeochemical floats out into the ocean. We're asking people who are going down there anyway to launch a float for us. These floats will go out into the ocean, drift around. They'll spend most of their time at 1,000 meters. Every 10 days, they'll go down to 2,000 meters, and then they'll do a vertical profile up to the surface. When they get up to the surface, they'll transmit to a satellite all the data about the ocean that they've just passed through, all the biogeochemical data, and then they'll go back down to 1,000 meters. They'll do this every 10 days for 5 years. And we're putting these all over the world. We're trying to deploy about 130 of these floats every year. And that's a program not only called SOCOM, which is where we started doing this in the Southern Ocean, but now we have a new program called GO-BGC, which is the Global Ocean Biogeochemistry Array, where we're putting them in the rest of the world ocean as well. And my part in this is the outreach part. And the reason I'm telling you about this is because I'm hoping some of the teachers and students might be interested in adopting a float. We have about 120 floats every year that are looking for people, classes to adopt them. There's no charge. There's a simple form on the website. The float should work up to 5 to 6 years, collecting and sending data, profiling the water column. We have data accessible on the website. There are lesson plans available. We're creating more. And we're also going to be running teacher professional development workshops in 2022 and 2024. It's a very simple process. You adopt your float, you give it a name, we throw it into the ocean, and then all you have to do is start following the float, where it goes, and the data it's collecting. And this is an example, again, of what the profiling float looks like. Some of the data it collects when it's out there working, and it's using a buoyancy engine. It's pushing oil back and forth to go up and down in the water column. And as it's going out there, it's collecting all this data and then bringing it back and sending it to our satellites. And from our satellites, it's going directly to our website where you could access it. And this is in near real time. We have on our website all the information about how to access the float, how to see your float, how to track your float, because when you adopt a float, your float is put into the database with your name, your school's name, or your group's name, and it will be there forever, or as long as we have funding. So hopefully forever. But you could access and then plot your own data using these floats or anybody else's float all around the world. So it's a really fascinating way to use and manipulate the data. And the last program I want to talk about was our internship program for undergraduate students, graduate students, and educators. We have a full-time research internship program in the summer, 10 weeks. Stipend is about $17 an hour. 2022 will be our 26th year. We're hoping for an in-person program. We'll open the applications in November. We'll close in February, and we'll make our selections in March. And if you follow us on social media, you'll be kept up to date on all of these opportunities as they come up, or you could just take a look at our website. And with that, the only thing I'll add is that Jeannie was talking about the amazing amount of biodiversity on land. And I'll remind everybody that 95% of the available living space on Earth is in the ocean. And we can't even tell how much biodiversity we're losing because we don't even know who lives in the ocean yet. So we're still exploring and trying to find out what's going on in the ocean, and our social media tags are below. Thank you.